This is a pretty early Prinztronic from Dixon's International, made in Japan. Calculator, Prinztronic Micro. It's got a fairly uninteresting keyboard, and this one's got some pretty heavy battery corrosion. The battery label is soaked in something, but interestingly it just slides off, so the battery compartment's a completely self-contained unit. And it's got these slide connectors here. I have no idea if this works or not. I suppose I could wire it up to the supply and see, but I'm more interested in how it's made, because there's actually a connector there which is connecting the keyboard unit to what looks to be the processor. I think that just pulls off. That's look at that. That's an amazing little bit of engineering. You won't get that in a modern calculator. So the keyboard is modular, and the processing unit is completely modular as well. I mean, this is a world away from some of the calculators that I've taken apart. Now the on-off switch, you seem to have to push that in to move it. Oh, fascinating. So that's got some really old, really old 7-segment displays there. Unfortunately, they look a little bit corroded, and that's a shame because they're really nice. And what's happening there? So once more, so it looks like, once you've unplugged the keyboard, there's another connector here. It looks like you can just pull that apart as well. It just comes apart like Lego. So that's the display. That's one unit. This is quite an amazing construction. I've not seen anything like this before. And then underneath you've got the ceramic Toshiba T3103. I have to look that up. That's in an interesting ceramic package. What else have we got? We've got a Toshiba T1271. Wonder what they are. No date codes. That's a shame. I wonder what date this is. But you can take the whole thing apart. It just clips together. It's just brilliant. So that goes back in there. Like that. And that goes back on there. Not that way, that way. Look at that, it's just brilliant. And then the battery compartment pushes in on there. Just unclogs. I wonder how reliable that was. Well, they are gold plated contacts. I'm tempted to get this powered up now. Does it have? Oh yes it does. So here we've got V and what's that? 0V, so that must be the minus. That one there must be the ground. And that one there will be the plus. Let's power it up and see if it does anything. Got some wires here and a power supply. Let's try putting the minus. So what was that? 4 batteries, so it's going to be presumably 6 volts. So that does say 0V, so let's go with that there. Looking at the displays though, they look to be not in the best of shape. So no keyboard, let's just see if something happens. Is it on? It's off. Let's turn it on. It's bit of current going, we're up to 100 milliamps, 2 volts. Nothing's happened. See no display. Hopefully I've got that the right way around. That's taken a hell of a current. Wondering if that's the wrong way around. I think that's the right way around. So where would the plus be? The plus would have been there, which is there. That seems to be the other way around. So that would have gone in there. Like that. So the plus of that battery would be there. So no, it's the other way around. Oh dear. Looks like that's the plus. Which is labelled. Oh, maybe this is a. Oh well. A lot going on here, is there? Some sort of LED. Something going on. You can see there's digits coming on. I must have had it the wrong way around originally. That's a shame. Have I killed it? Let's try again. Let's just put that in there. See if the keyboard does anything. So I think it was plus there, minus there. Oh, I don't know if you can see that, that's actually working. I've got a 0 there, bit dim. Let's see if I can get a better display of that. Do I want to plug that back in? No, not really. Let's use the case. Okay. There we go. Can you see that? No. Let's see if I can get a closer view of that. Switch off some of the lights. Let's switch off all the lights. It's a bit more visible. One works, 2, 3, 4, 5, 6, 7, 8. I'm surprised those LEDs are working. That is working, it looks like. It's got a constant LED there. I don't know what the B LED is. Is that for battery? Let's drop the voltage down, yeah. So the battery LED comes on as the voltage drops. Down to 4.5 volts. So it comes on at about 5.3 volts. Interestingly, it gets brighter as the battery voltage drops. At 6 volts it's working. Let's check all the digits, all the segments. Yeah, they are actually working. That is quite surprising. The on off switch works. So that unit does work. And if I cleaned up the battery contacts, it might actually work. It's a basic 4-function calculator though. How does that work? So 10 plus equals gives me 10, 20 plus equals gives me 30. And that's interesting. So there's no equals key, there's a plus equals and a minus equals. 63 minus equals, and it's got negative. So it can do negative. I wonder what it does for an error. 2 divided by 0. There's the error digits, decimal points everywhere. Let's turn that off. I think we can get the keyboard out. like to see the LEDs working on their own. That's corroded a bit there. Ah, it's not going to come out. That is amazing construction. Plastic's a little bit worn there. Let's put some light on that. Look at that. That's worth keeping just for the construction, just to take it apart occasionally. Look at that. They're high quality connectors, because they're fine, there's nothing wrong with those. Keyboard is a bit problematical, can't get it that out. Need a bit of screwdriver. And it looks like the keyboard itself, the actual keys can be dismantled as well, because there's some screws on the PCB there. Might dismantle that fully, do a full sort of tear down on that. Let's see if I can get the keyboard out with a better screwdriver. Let's try something with a bit more torque. That's not working. I can get that one out. That's turning. Let's see if we can get this one out. No, that's a shame. It's corroded. The batteries have gone. It's a shame. Let's get that out. That is such a nice construction. I'd be tempted to look for another one of these. Fairly tight fit in there. Let's see if we can get that out. Have to drill it out or something. Let's see if we can do it with a flat blade. It's going to destroy the screw. Is that the right size? It's probably the right size. No. Might even destroy the screwdriver. Right. It's not coming out. See inside the keyboard just to see what the construction of that is. That's a real shame. I have to drill that out on the mill. That should, let's see if it'll come out. Shame. I'm tempted to take the PCB apart and have a look. Some sort of insulating. Is that necessary? I'm not sure that's necessary. Insulating sheet there. Those screws. Fine in there. Yeah, they've been protected, they're fine. That's not quite the right size. Key construction feels like there's springs in there, so this could all go ping. Let's have a look. Sticky label there. Got 71 on it. Oh, look at that. It is springs and a membrane. That's interesting. Is that bonded to that? Not really. Oh, look at the fine tracks there. So there's carbon contacts going to a very fine switch track. And there's a spring for every switch. Look at that. And the springs fit into the key switches. Oh, lovely. A bit dusty. So that is high quality stuff. Let's put the sleeves back in. It's amazing for such a basic calculator, although at the time it probably wasn't that basic. Amazing construction. I just wish I could get the remaining screw out. I think a couple more years, a few more months of battery corrosion would have killed this completely. As it is, it's actually functioning, which is a big surprise. These LEDs really don't look good. Maybe they were built like that. There's one there with a lot of frosting on it. I wonder what the date is. I can't find a date code. The only date code on there is 3G. No, I don't think that's a year. I wonder what the actual date of this is, even on the other chip. 3Es, now they look to be some form of batch code or something. There's a transistor there, that's Toshiba as well, so Toshiba definitely had a lot to do with this. And just plug it all together again. Oh. Fantastic.